All right, honors geometry class. I promised I'd send you a video. I'm not sure how great this was going to be, but we got to the Pythagorean's converse, the converse of the Pythagorean theorem. We started in Pythagorean's theorem in a right triangle, then a squared plus b squared equals c squared if we have that triangle. But now we are going to have the converse of the Pythagorean's theorem. And it reads, if the square of the length of one side of a triangle is equal to the sum of the squares of the lengths of the other two sides, then the triangle is a right triangle. So if we've got three sides of a triangle, C, A, and B, C should always be your longest side, because if it is a right triangle, then it's going to be your hypotenuse. So comparing c squared to a squared plus b squared. I have it particularly oriented that way because there are two theorems that branch off from c squared. For instance, what if c squared is not equal to a squared plus b squared? Our options would be what other kinds of triangles? Thinking about it. Obtuse or acute triangles. So we're going to be comparing c squared to a squared plus b squared. Is it greater than, is it equal to, or is it less than? But first let's see an example related to determining, do these lengths form a right triangle? So my c squared, this is going to be my c, change my colors, c, and then a and b are kind of interchangeable. My c squared equals 7 squared, or 49. And then I've got a squared plus b squared, and that's going to equal 4 squared plus 6 squared. So 16 plus 36. And that would give us, I believe, 52. So is this a right triangle? Does 49 equal 52? The answer is no. So it is not a right triangle. Which then leads us to the question, well, what happens, or how do I compare it if it's not a right triangle? And that brings up the next two theorems. Now, lots of words where we can summarize it in symbols. If the square of the length of the longest side of a triangle is greater than the sum of the squares of the length of the other two sides, then the triangle is obtuse. Okay, the triangle is obtuse. First of all, if you compare c squared to a squared plus b squared, you're going to read the inequality so it'll be c squared being greater than a squared or b squared, right? When I see this symbol, c squared is greater than a squared plus b squared. If you put it in that order and c squared is greater than, you will get an obtuse triangle. Then I'm going to write an equivalent statement that messes people up. And so it's just a warning. I'm going to give you another way to think about this. But first, if I read this, this would be a squared, right, plus b squared is less than c squared. Do I still have an obtuse triangle? I do, because when I look at c squared, it is greater than a squared plus b squared. But when I read that statement from left to right, I'm going to get confused. So make sure you're looking at that. Okay, I'm looking at the c squared compared to the a squared plus b squared. The way I like to think about it, and maybe I should do it with an example, is when I have an a squared and b squared, it's as if I've got a right triangle, and there's this hypotenuse, right? There's this hypotenuse that goes with it. I'll call it h for hypotenuse, right? There should be this hypotenuse based on a right triangle. And if my c squared, or my length of c is bigger than I anticipated, longer than I anticipated, then my triangle is obtuse. So I like to use my hands to form a right angle. My a squared plus b squared is going to form this right triangle with this hypotenuse. And if my c squared is larger, my hand opens up, and I'll show that to you tomorrow. On the opposite concept is an acute triangle. If the square of the lengths of the longest side of a triangle is less than the sum of the squares of the lengths of the other two sides, wow, mouthful, then the triangle is acute. Again, comparing c squared to a squared plus b squared. If c squared is less than a squared plus b squared, then the triangle is acute. Again, if I do an a squared plus b squared, an a and a b, and I find my hypotenuse for a right triangle, and it's less than what I would expect, right? It's less than what I would expect, then my angle has to be acute. Okay, that's really messy, so I apologize for that. But if you get that point, I look at what I would expect, and if it's shorter, right, than what I expect, it's going to be acute, okay? So I put these up here just to make sure you see. If I read it from left to right, I'm going to be confused. If I read it left to right, I'm going to be confused. So make sure you're looking at the c squared. The longest side is 13, right? And it's greater than, obtuse, right? If I look at the longest side, that's 14 compared to a squared plus b squared, it's less than, acute, right? So don't just trust the statement reading left to right. If I were to read left to right, I would think it would be an obtuse, but the reality is I need to compare the longest side squared to the sum of the other two sides squared. Okay, so C, right, 22 is the longest side, and it's greater than, I'd be obtuse. And then looking again at the c squared, the longest side squared is less than, so this will be acute. Okay. Again, we'll go over the visual of that and try to get that finalized. Okay. So, just to finish this up, these are the last examples. What kind of triangle do I have? Acute, obtuse, or right? First, I find my longest side, 25. So it's my c squared equals 25 squared, or 625. And then I'm going to have my a squared plus b squared. And I'm going to put it to the right of it, a squared plus b squared. And that's basically 225 plus 400, right? So the 15 squared plus 20 squared, and that equals 625. So since these, right, 5 equals, I have a right triangle. I'll go into B and see how that works. My longest, again, is 20, so c squared equals 20 squared, or 400. And then my a squared plus b squared is going to be 10 squared plus 15 squared. So that's 100 plus 225, or 325. So 400 related to 325 is greater than. So I'd be expecting a hypotenuse of the square root of 325, or the hypotenuse squared of 325, that's what I'd expect. And what I'm given is 20 squared, or 400, which is greater. So I would expect something with 325, right? And what I'm given is longer, right? The total of 400. So I have an obtuse triangle. C squared is greater than a squared plus b squared. And then finally, I'm going to do part C just to demonstrate. C squared, clearly it's going to be acute, because why would I do 2 of the others? 15 squared, 225, and then a squared plus b squared is going to be 12 squared plus 13 squared, so 144 plus 169. I already know without adding that up that it's greater than, but I'll try to do my math. There's a 3, right, 313. So 225 is less than 313, so it is acute. Again, I've got a right triangle and I'm expecting 313, and what I'm given, right, is just 225. So it's going to be an acute angle. That's all you missed, but I know it is a little more complex than just using the Pythagorean theorem, determining if it's acute, obtuse, or right triangles. I hope that helps. Maybe check online to see if the book online has some good videos too. I think that's it. I hope you had a good night.